You can't help but find it entertaining that a lot of truck companies want to demonstrate their alleged power and torque by towing a bulldozer and a flat trailer on level ground on some dirt road. And for the three of you in the real world who actually get to do that, must be an interesting ad. But if you want to find out what a truck can really do, let's put it to the extreme test. Let me set this up. See, traditionally, gas-powered turbocharged engines made power at higher revs. That's been their weakness. They were limited to fixed settings, which simply didn't allow for any kind of flexibility. They had fixed ignition timing and fixed valve timing. Well, that was then, and this is now. Modern electronics control everything on an engine and can reconfigure the power band to exactly what the driver requires. Now, the ignition, the injection, the cam timing, and even the transmission calibrations can all respond to the reaction of your right foot. Pickup drivers, welcome to the future. Oh, I know what a lot of you are thinking. Does it have enough low-end torque that customers have come to expect? And can it pull a huge, I'm talking 8,000-pound boat out of the water on a steep, wet launch ramp? That's a major concern for any boat owner. I understand. Let's see just how low we can go and EcoBoost still pull this monster boat out of the water. With this powertrain, that was way too easy. This is what they call a cam phaser. This is on the EcoBoost engine. To be honest with you, there's 4 of them, 1 on each camshaft, 2 on top of each cylinder head. It allows for the twin independent variable camshaft timing, meaning this gear and this cam are not fixed. They can move. The cams can take the motor to make it, well, all the power available at the very low or the middle range of the RPMs, or they can really lean it out to save fuel economy on the highway. Fixed camshafts are old thinking. These engines are constantly tuning themselves on the fly. Now Ford has a truck as smart as it's strong. Turbo lag, or to be more precise, the failure of the engine to respond to the throttle pedal, has been part of the automotive history like it was some kind of law of science. Well, consider the law rewritten. This F-150 with EcoBoost displays none of that throttle delay found from years ago. Perhaps the best way to show immediate response to these turbos is to simply compare the speeds of the F-150 as it accelerates around this 75-foot rig. We pace his speed at exactly 50 miles an hour, ready to try a pass. At the start flags, the EcoBoost will go to wide open throttle. We are watching for tachometer response, speedo response, and rapid downshifting, and the gap we maintain behind this 75-foot rig. Now that may seem a lot to look for in a short time, but with split screens, we'll show you that in an instant and from many different perspectives. If EcoBoost suffered any turbo lag, our test rig would fall back, or a bigger gap would develop before the EcoBoost finds the power to pass. At 50 mile an hour, a pass like this is a moment of truth. Let's see what happens.
At steady state at 50 miles per hour.
Notice the pull is immediately available. This engine doesn't bog down or decelerate when you ask it to perform. In fact, just the opposite. It's all power. Now, let's try it from a little harder speed, 40 miles an hour.
At steady state at 40 miles per hour.
Notice the instant response from EcoBoost at this speed. Now, let's try it one more time, this time from a very challenging 30 miles an hour.
At steady state at 30 miles per hour.
And once again, no turbo lag. This is asking the most from this engine. Team this design with lightning-fast variable valve timing, direct injection, and sophisticated electronic ignition, and you understand how Ford has rewritten the old turbo playbook. Modern science has pushed the internal combustion engine into the most efficient form of transportation on Earth. Leading that charge is Ford Motor Company. Modern engines are cleaner and more durable, But there's a never-ending quest for more horsepower and torque, not to mention fuel economy. One of the methods for making that happen is the use of small turbos. But it begs the question, do I have to sacrifice durability in the interest of power, torque, and better fuel economy? The answer is a flat no. Not with Ford's truck-built EcoBoost engine. This block is all about long-term durability. Give an example, a forged crank. That's my first hint they were playing hardball on the long run. And then I learned that they not only bolted the main caps the way we're used to on the bearings, they cross-capped them as well. This is the turbo for this engine. It's a Borg Warner. As you may be able to tell, it is now factory sealed. This requires no servicing for the life of the engine. Now, if you're familiar with the old days, where turbos notoriously burnt their lubricating oil, it was referred to as coking, it required you to actually leave the engine running for a while after you parked. Those days are gone. So using this turbo and two methods of cooling, not only oil, but water as well, you pull up, you shut the engine off and start across a parking lot. Using non-mechanical siphon, this turbo continues to cool itself. This is our second piece of evidence that they were playing hardball in terms of durability. Now this engine is going to make a lot of power and a lot of torque. So how do you make the pistons live? Because this is where you make it at. Well, you emulate, and boy, who better to do it? You emulate your diesel top piston ring for sealing. Talk about long-term durability and the ability to get that power to the crankshaft. That's how you do it. All right, our third piece of evidence is somewhere we didn't expect to find it, because frankly, no one ever thinks of it. Look at this oil pan. Now you say to yourself, how does that contribute? Well, look at the depth of it. It's designed to carry more oil in the sump. This helps keep the lifeblood of the engine cooler. But we love the strength. Not only does it make it quieter, but it strengthens the block as well. That's attention to detail. That's how you build long-term durability. What I'm about to tell you, well, frankly, is likely to surprise you, because I'm about to outline the things you don't have to do to maintain your F-150 EcoBoost engine. See, people automatically assumed that because it has twin turbochargers and frankly is state-of-the-art sophisticated, that it was going to require extra service or more adjustments or perhaps even the expensive premium fuel. Guess what? They're wrong. In fact, EcoBoost even runs on regular grade fuel, not expensive premium. So save your money. You'll get all the power and mileage you could hope for all day long on regular. Here's a major plus for cost of ownership. No special motor oil is required for EcoBoost. And even a bigger surprise, it now is good for 10,000 miles between oil changes. So how are they doing that? Well, on all the new F-150 engines, they now have a standard integrated oil cooler to keep the operating temperatures of the oil down, and more importantly, to keep it from breaking down prematurely. You might find there's actually less to do when you own an F-150 with the EcoBoost. In fact, I know of two things you'll never have to do again with this truck. You'll never need to check the automatic transmission fluid. It's sealed for life, so that's history. And you'll never need to top off the power steering fluid, because there isn't any. Ford got rid of all that. In terms of technology, I guess you could say Ford's moved on. Consumers expect mileage improvements in every vehicle today, and pickup trucks, frankly, are no exception. Remember, for many pickup truck buyers, fuel costs represent overhead, and these days, we're all looking at those kind of expenses. In terms of improving mileage, there seems to be a clear split in the engineering that has come to the marketplace. The idea on how to save fuel seems to be following two distinctly different paths. Silverado and Ram have conventional V8s that admittedly have been refined many times over the years of production. The one idea that both companies have adopted is what they refer to as deactivating or killing half the cylinders of their V8s when they can, like in the case of, well, running down a flat stretch or highway or under no load. They can save a tiny bit of fuel by using this technique. The problem with this design is you continue to have that rotating mass. The dead cylinders, well, they're still spinning around, still moving up and down inside the engine. Cutting an engine in half while still carrying the other half, really not the practical approach. Let's take a look at a better idea when it comes to making mileage. In fact, just the opposite of what Silverado and Ram have done. The F-150's EcoBoost design offers the best combination of power, capability, and fuel economy. See, EcoBoost has direct injection and variable valve timing to efficiently use every morsel of fuel. The twin turbos recycle the energy from the exhaust to put more air and performance into the combustion chambers. Unlike the V8s, it sips fuel all the time, but also has the instant boost in torque when you demand it. The effectiveness of these two engineering paths is easy to verify. Just check the EPA mileage numbers on the window stickers. Compare them all. The proof is hanging right there. The F-150's EcoBoost engine is available in every cab and in 6 different trim levels, available in 2-wheel drive or 4-wheel drive. They're not trying to limit it to one knockoff special fuel mileage maker. They're offering it across the board. So now you can save fuel in any combination you want. Come on, doesn't that just make more sense?